All right, so what we're talking about, and we'll just start kind of over, is that ionic bonds. All right, ionic bonds, nothing new. Pluses, minuses, good. Now, I'm going to mess with the whole covalent bond thing. Since I can't go off camera now, basically what we've got is everybody over here to this side of the line are the only ones we're going to care about for covalent bonds. These guys don't covalently bond with anything. All right? All the metals, they can do that metallic bond thing I mentioned yesterday, but no covalent bonds. Good so far. Okay. Now, we need some things. We're going to talk about things called electron dots. Some of you have had electron dots, some of you haven't had electron dots. The idea is the outer S and P electrons. So if I talk about hydrogen, it's got one dot because it's only got one electron. If I talk about carbon, it's 1s2, 2s2, 2p2. So I'm not going to look at the inner ones. Carbon has 4 dots. Good so far. Okay. If I look at oxygen, how many dots?
6.
6. So it's going to have 6 dots. Now, when you draw the dots, somebody might have told you to go on the outside edges of a box and pretend that there's two on each side. And we'll talk about why later. All right? Let's say there's 2 dots, like that. Okay? So those are the electron dots that they would have. And what you may or may not have seen last year in first year chem is like oxygen, if it were to bond with hydrogen, would share a dot. Okay? Oxygen with hydrogen share a dot. So that would be a bond pair. Okay, so pair of electrons in a bond. Now a bond, we're going to draw a line to show a bond like a pair of electrons. If you remember from the stupid example, I'm holding on to electrons, he's holding on to electrons, we're not letting go, that's a covalent bond. Okay, so another way we could draw this is just like this. So that shows a couple of unbonded pairs. All right, these are unbonded. That says B. All right, and then these two are bonded pairs. Okay, they're being shared between the 2 atoms. Good so far. Okay. Now, this one here is kind of weird because carbon. Can you make sure I'm still in frame?
Yeah.
Okay. So because carbon has 4, you would think 1s2, 2s2, 2p2. We're going to ignore those. It has 2 in the S. You'd think it would be like this with 2 in the S and then the 2 in the P. Because those P ones are in their own little orbital. All right? So this is what you think because it's kind of like that. All right? But what most atoms do if they have 4 or less electrons, and even if they have more sometimes, is if we look at the 2s and the 2p, what happens is these this electron here kind of promotes, okay? And it moves over into this empty space. Even though that's a little higher energy, what it does is it makes 4 bond sites that all have an electron. Okay? It's a little bit higher energy than S, but it's a little bit lower energy than P, so it's more stable. And so it gives carbon 4 distinct places to bond. And the way we call this is we call this a hybrid orbital. Hybrid. What's the word hybrid? When you think of hybrid these days?
Car.
Hybrid car. Okay? Because it's got gas and electric. So this kind of loses, this is kind of S and P getting together. It's like if you breed a white rose with a red rose, you get a pink rose. Right? You breed a white horse with a red horse, you get a pink horse. It's called a roan. All right? So we're looking at the dots being each having a bond site. All right, so we got 4 bond sites. So like the simplest bond would be carbon. If it bonded to hydrogen, how many hydrogens could fit? Let's keep the same color scheme. How many hydrogens could fit?
4.
Well, each hydrogen's got 1 to share with the carbon.
4.
So it could get 4 hydrogen. 1 hydrogen could come in here, let's share. Another hydrogen come here, let's share. Another one in here, let's share. Last one, let's share. And this would make methane. The stuff when you pass gas that burns. All right. So this, how many of you saw something like this first year kid? Most of you? Okay. Don't you not raise your hand, you were in my friggin' class. I know I taught this. I feel something. Go home and cry some more. All right. Now, everybody's seen that part, right? Now I'm gonna mess with you. Yes, I am. Don't you shake your head. All right. So here's how we're gonna do this. Okay? What we're gonna do. Well, let's see. Okay. Try this first. Actually, no. Let me just give you the rule. Okay? Let's say we're trying to build CH2O. Okay? Here's how we're going to do it. Am I still in frame the whole board?
Yeah.
Thanks. Okay? CH2O. All right? Here's how we're going to do this. We're going to count the number of electrons we have available. How are we going to do that? We're going to go, okay, carbon. How many valence electrons? 4. Remember, because it's got the 2s, 2, 2p, 2. How many electrons does hydrogen have available? 1. How many is oxygen? It's 2s2, 2p4, so it has 6. Okay? There's only 1 carbon atom, there are 2 hydrogen atoms, and there's 1 oxygen. So we add up and we go, okay, how many electrons do we have? That's 4 plus 2 plus 6, which is 12. Okay? So we have 12 electrons to spread around. Okay, now, here's what we're going to do. Usually, I'll just tell you this, usually carbon is in the middle because it's got 4 bond sites, which is a good thing. The reason you exist is because carbon has 4 bond sites and is covalent. Because what are you made of? Almost all carbon, hydrogen, oxygen, nitrogen. Little bits of other stuff, but for the most part, that's it. Right? So if I threw you in water and you were ionic, that would be a problem. You would just dissolve. So we're going to make and put carbon in the middle, and we're just going to hook everybody to it, and we'll try that and see how it works out. So we're going to bond hydrogen there. We're going to bond hydrogen there. We're going to bond oxygen there. Okay? Now, how many electrons is that? 2, 4, 6. I'll give you a hint. Line equals pair of electrons. So if you can you guys count by 2s?
Yeah.
Okay, good. I'm not being facetious. There are people who cannot count by 2. Okay? So I've used up 2, 4, 6 out of my 12. Okay, now let's think about this. If hydrogen is 1s1, how many more electrons can hydrogen take? 1. So hydrogen can only have 1 bond, ever. So hydrogen has the number of electrons that it can possibly take. Pretty good? Okay. Now, if we look over here in this corner, let's see, we're just going to ignore the noble gases, right? There's fluorine, all right, chlorine, bromine, we got oxygen, sulfur, blah, blah, blah. We got nitrogen, phosphorus, blah, 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 all right? We got carbon and silicon, okay? And boron and aluminum. We're not going to worry about aluminum because it's a metal. All right. Now, there is a rule that these guys here, are they strong or weak? They're really strong, right? So these guys want to fill up, their outside shell. So they have to have 8. It's called the octet rule. They have to have 8. Absolutely have to have 8. These guys have to have at least 8. Usually, there's a couple of weird exceptions, but for the most part. Okay, now why is that? Because these are all the strong ones. But these, are they big or small?
Small.
Small. Mouth, then brain, not good. Brain, then mouth.
Brain now.
Brain, then mouth. Ready, aim, fire, not ready, fire, aim. All right? So these guys are small. So it would be really crowded to put more than 8 electrons around. These guys can hold a little more. Sometimes you can get 8 or 10 or 12 around there. Okay? So they both want 8, and the max they can have is 8. Now how many electrons does this carbon have so far? 6. So we got to give it some more. Okay? Now one way we could do that is go like that and say, okay, it's got an unbonded pair. Alright? Like oxygen, if we drew oxygen, it would have 1, 2, 3, I think I drew it on the other board. It'd be like that, right? So it'd have a couple of unbonded pairs. Okay, is that all 12?
Yeah.
Okay. 2, 4, 6, 8, 10, 12, okay. Now, does oxygen have all 8?
No.
How many is it at? 2, 4, 6. Carbon's got its 4, it's 8. Hydrogen got its 2, but that's not okay. So what's another way? Well, instead of sharing 1 pair of electrons, we could share 2 pairs of electrons. You ever heard of a double bond?
Yep.
All right, it's a double bond. We're sharing 2 pairs. Now, does oxygen have its 8? 2, 4, 6, 8. Does carbon have its 8? 2, 4, 6, 8. Is everybody satisfied? Are we good?
Yeah.
Yes, ma'am.
So why didn't we put the dash or pair below the O? Can we just
Oh, as opposed, if I wrote it like this, that's fine.
Yeah,
All
okay.
right, if I write it like this, that's fine. It's just, I don't even think there's a convention for which sides you're supposed to put it on. There might be, there probably is a rule, there's a rule for everything, but it's fine.
So we need triple bonds.
Triple bond,
Yeah, so we.
we'll get there. All right, so here's what I'd like you to do. The only way to get good at this is to practice. So what I'd like you to do is I'd like you to practice, get out your sheet, work on number 7.